Okay, so section 10.4 is going to talk about perimeters and areas of similar figures. So again, we talked about similar figures back in chapter 7. So again, how do the perimeters and areas of similar figures compare? Okay. Well, again, before we start anything, the most important idea between similar figures is that the fact that their shapes are the same, but their size is different. And the size of your figures is controlled by the scale factor. So I hope that you're thinking, okay, well, this has to do with the scale factor in some regard, because you'd be correct. Okay. All right, so here is the main idea. So if two similar figures have a scale factor of A over B, again, those can be numbers, 3 to 2, 1 to 4, okay? The ratio of their perimeters, the perimeters is still that A over B. But the ratio of their areas is going to be A squared over B squared. To try to remember this, I want you to remember that perimeter is in units, but area is in units squared. So think of that when you're looking at the ratio of these perimeters and areas. Use this as a hint. Okay. Now, on the next slide, I'm going to demonstrate why this is the case. So I have two right triangles here, okay? So we're going to call this the small right triangle and this the big right triangle. So I would like to find the perimeter of the small right triangle. Well, you just simply add up the sides. 3 plus 4 plus 5. That's 7 and 5. That's 12. And that'd be units. So the perimeter of the big triangle, I'm going to add up these three sides, would be 3n plus 4n plus 5n. Well, what I can do, right, is if I add these up, I get 3 plus 4, I get 12n, where n is my scale factor. So if I compare these two perimeters in a ratio, big over small, that would be 12n over 12. The 12s would cancel, and there's my scale factor n. The perimeters equal the scale factor. Now, what if I do the areas? Okay, well, let's find the area of the small by taking 1/2 the base times the height. Half of 12 is 6. And let's find the area of the big. I would take 1/2 the base times height. Half of 3 times 4 is still 6. And n times n is n squared. And if I compare the area of the big to the area of the small, sorry about the bell, that would be 6n squared over 6. The 6's cancel, and there is your scale factor squared. Okay? So again, the reason that the ratios are the way they are is due to the fact of perimeter being addition, one-dimensional, versus area, which is multiplication, two-dimensional, n squared. All right, so let's take a look at some questions on edge elastic. Again, these are pretty quick, as long as you understand the scale factor and your proportional reasoning, okay? All right, so let's get to the first question here. So it says the trapezoids, let me tell you, that's fine. The trapezoids are similar. What is the ratio of the perimeters? What is the ratio of the areas? So if you notice that they're similar, you need to find the scale factor. And to do that, we're going to use a pair of corresponding sides, which are the 6 and the 9. I don't care how you do it, 6 over 9, 9 over 6, just stay consistent. I'm going to go 9 over 6. Both are divisible by 3, and that's 3 over 2. You could put 1.5, I suppose, but I'd prefer the fraction. You could also have done 2/3 or 2/3. Now, I don't think you can put 0.666. I don't think they'll count that. So again, stick with fractions. All right, so the ratio of the perimeters, so I would put 3 divided by 2, because the ratio of the perimeters is equal to the scale factor. This is equal to the scale factor. Now, the ratio of the areas, because area is square units, is equal to the scale factor squared. So we're going to take 3 squared over 2 squared. 3 squared is 9, 2 squared is 4. That's 9/4. And again, try to avoid decimals if you can. If you answered 2/3 for the first one, then your second answer would be 4/9. Just try to stay consistent. Next question coming. Okay, so now it says the area of the smaller regular pentagon is 27.5 centimeters squared. What is the approximate area of the larger pentagon? Round to one decimal. So again, we're doing an area. This should say area, sorry. We're doing an area problem. So when I look at these two figures that are similar, I do see a pair of corresponding sides. So let's first find the scale factor. So the scale factor is 10 over 4 divide by 2 divide by 2. That's 5 halves. Now, if I'm talking about area, the ratio of the areas is equal to the scale factor squared. So what is the scale factor squared going to be? Well, it's going to be 5 squared over 2 squared. That's 25 over 4. This is the ratio of our two areas. Well, we can set up a proportion using the scale factor and then the areas in a ratio. So our scale factor is 25 over 4. Obviously, that's big over small. So when we put our areas, we have to put the area of the big figure on top and the area of the small figure on bottom. So 25 over 4 is going to equal, now they give us the area of the smaller figure, 27.5. That's going to go on the bottom. And we are looking for the area of the larger figure, that's our x, which goes on top. And this is simply a cross, multiply, and divide. This is a proportion, cross multiply. I'm going to come up here with it. The x gets multiplied with the 4 to become 4x. On the other side, I'm going to multiply 25 times 27.5. When I do that, I get 687.5. Sorry, 687.5. And then, again, I did it again. I'm trying to do two things at once. Type in or write 687.5. Did it. Yes. And now to get x by itself, divide by 4. You divide that by 4. You get a decimal answer of 171. It says round to one decimal. So without rounding, it says 0.87. We have to round to the 8. So the 7 does round the 8 up. That'd be 171.9. And I will show you when you do this, right? So that's my answer, 171.9. It should be bigger because, the bigger figure should have the larger area. 171.9. Oh, when you put that in here, 171.9, you do have to pick the units. And again, this is centimeters squared. These are both in centimeters, so your units are centimeters squared. I'm going to stop this video, and I'll make a second video covering the last 3 examples.